In this video, we are going to learn how to set up a column for column chromatography and then learn how to run a column. Column chromatography is a technique that follows the same principles as thin layer chromatography, where we use a polar stationary phase and less polar solvents to separate compounds on the basis of polarity. The difference with column chromatography is that we can do large quantities of compounds and purify entire reaction mixtures so that we have purified products to use for the next step in a sequence or to get better characterization of. In this experiment, we are going to be using a very, very small column because we're going to be working with a small amount of material. Now, our first step is that we need to put a plug into our column because our stationary phase, which could be alumina or silica gel, are free-flowing solids, and if we just pour them into the column, they will fall out the bottom. So as a plug, we use either a small amount of glass wool or a small amount of cotton, and we'll just put that into the top of our column, and then we can use a pipette to stuff that in. Now, you have to be careful when you are preparing the plug for your column, because if your plug is not tight enough, not secure enough, the stationary phase will fall right through the column. On the other hand, if your plug is too tight, then your solvent won't be able to get through the column and it will also be unsuccessful. So for this separation, I'm going to be using alumina, but we could also use silica gel. And so I'm going to pour out a predetermined amount of alumina, and so we can see it's now sitting on top of the silica gel. Now, before we're ready to actually run our column, we need to wet the column with a solvent. And so we generally start with our least polar solvent. And so in this case, that's hexane. And so I'm just going to add some hexane to the column and let that fully come through the column. Once the column is completely wet with hexane, we'll then wait for the level of hexane to come down to the top of the alumina before adding on our mixture to be separated. Now, the mixture that I'm going to be separating in this video is a mixture of fluorine and fluorinone, very nonpolar fluorine being just a hydrocarbon, and fluorinone being more polar, containing a ketone. And with this mixture, we will be able to see visually some of what is going on because fluorinone is yellow, fluorine is white, and so we will be able to see the more polar fluorinone eluting from the column based on the yellow band. So now we're just waiting for our level of solvent to come to the top of the column. Then we'll apply our mixture, followed by some additional hexane. We start with a less polar solvent because we want the compounds are coming off in order of polarity, and so we try to match the polarity of the first compound that's going to elute. We'll also notice that the yellow band from fluorinone, the more polar compound, is not going to move very far, and we may need to switch to a more polar solvent in order for it to come off. So as we can see, our level of solvent is starting to approach the level of the top of the alumina. So I'm now going to prepare to pipette a couple drops of our solution on. And again, we're going to wait till that level of solvent is just at the top, which it's now there. And so I'm going to add a couple drops of this solution, and then allow that to fully come onto the column. As soon as that has reached the top of the column, I will then fill up the column with our first solvent. Now, while we do have color to rely on, at least for the second compound, it's generally going to be safer to run the column by just switching to a new test tube at a regular basis. So what I'm going to do is about every milliliter, I'm going to switch to a new test tube. then in order to determine what is in each test tube, we can run a TLC by spotting each fraction, developing the TLC plate, and then based on comparing to known standards, we can determine what is contained in each fraction. So again, we're going to just watch this come off. And every so often, about every 1 to 2 milliliters, switch to a new test tube. What we can also see is the yellow band has moved only a small amount. At this point, our fluorine is probably starting to elute out the bottom of the column or is very close, but our fluorinone, the more polar compound, which we can identify by the yellow band, is still up near the top of the column. So again, now I'm going to switch fractions. And normally we might want to be checking these fractions while we're going to see when we're getting the fluorine off. But for the purposes of time in this video, as soon as the solvent gets to the top of the column, I'm going to switch to the more polar solvent. Our more polar solvent in this case is 30% acetone, 70% hexane. And once we add this, we should see the yellow band start to move much more quickly. If at that point it's still not moving quickly, we can switch to an even more polar solvent, and we have pure acetone for that purpose. So our level of solvent is right at the top. We never want to let the level of solvent drop below the top of the alumina. That can cause problems that will worsen our separation. So I'm now filling the column up with the more polar solvent, 30% acetone and hexane. Again, I'm going to switch test tubes. And what we should start to see is our yellow band is starting to move. Now I'm going to lower this below the clamp so that we can actually I'm going to remove this from the clamp entirely and just hold it. This is not something you'll generally want to do, but I want us to be able to see the yellow band moving down the column. And again, we're going to continue to change test tubes on a regular basis. And we can now see our yellow band has come most of the way down the column, meaning it's moving much faster than it was before. And we also know that the yellow band is our fluorinone. So in this case, because the fluorinone is our more polar compound, once the yellow band has completely come off the column, we know that our column is finished. Now at the top of we're starting to run a little bit low on solvent, so I'm going to add some additional solvent to the top of the column, and just for demonstration purposes, I'm going to switch to an even more polar solvent so we can see that that will speed up the elution of the yellow band even faster. So now I've added some pure acetone to the column, and again I'll lift this up so we can see it. I'm going to change test tubes again. And we can see our yellow band is now right at the bottom of the column. And if we compare what we're collecting in the test tube to some of our earlier fractions, we can see that we're now getting a yellow solution in the test tube as opposed to the colorless solution we were getting when we collected the fluorine. Once the yellow band is completely collected, we're done with the column, and we're just going to then let the rest of the solvent drain through.